break right before 9 because I have to set up my daughters in their classes. But let's see how much we could do in terms of seeing and understanding what we need to do for our SBA. Okay. So I think everybody should be seeing my screen. Yes.
Yes, sir.
Right. So in terms of the SBA, this is the lower 6 SBA. All right, the lower 6 SBA. Really and truly, we just want something to be able to develop, your skills in computer science. It shows some mastery of the syllabus. Okay, this is what you're supposed to do. You want to choose a problem for which a software solution is appropriate and create an algorithm that uses sequence, selection, assignments, iteration, everything that we've learned in program design and programming. Okay, you must represent your algorithm using a narrative. So you must be able to describe your algorithm, that is the solution to whatever problem that you've identified, in plain English. And also you have to do either a flowchart or a pseudocode algorithm, either or. Okay, I know it's been a while since we've done a flowchart or pseudocode since we jumped into doing C, but you are required to do it for your SB, all right? So you have to implement your algorithm as C programs. You have to have an array. You have to have no less than 5 functions, and you must use at least one file, all right? After you've done that, then you have to do a test plan that tests your solution to check your program for correctness. It's not, it's not that bad. I will go through with you all something that can guide us to what we need to do in terms of our program. The test plans are very simple. You just identify different test cases for different parts of your program, and you state how your program behaves. Okay, I will also give you an example of how that works. The narrative and pseudocode, right? I typically leave up to you. I typically leave that up to you to do. Ideally, you are to plan your solution using pseudocode, and then you implement it in C programming. But I say in the interest of time and for the fact that your pseudocode must match your program, I normally tell students I would recommend that you work on your program once you know what you're doing, and you then will create your pseudocode and write a narrative to match. Okay, because either way, if you write a narrative and pseudocode first, and then you do up the program and you make changes in the program, you have to go back and reflect those changes in the narrative or pseudocode. You could do it either way, okay? So once you have that narrative pseudocode, once you have that program, and once you have that test plan, then your SBA is complete. All right. So we shouldn't have more than 1,500 words in the SBA. This doesn't include words included in diagrams, graphs, tables, and the bibliography. Right. We have different sections of the project. Right. CXC changed the project a little bit, but it's still as it should be. You should define your problem. Narrative, you should have your narrative and flowcharts or pseudocode as a section. You should have the coding of your program as a section, and you should have your testing and presentation as a section. This communication of information section is for me, and I will see how you brought across your ideas and how you worked on what you had to work on. Now, the thing is that I typically try, this is about 6 marks. This section is 10% of your SBA. I normally try to give everybody 5 or 6 out of this. So you are starting with, 8 to 10% in the bag. As long as you communicate, you speak well, you write properly, right? You get your ideas across clearly. Once you do that, your communication of information marks is there. So you have to try to lose communication of information marks more than you have to try to gain it. If it is that as long as you read over, as long as you go through your own project and you look at it and you say, hey, yeah, this makes sense. You say, hey, yeah, this makes sense. Then that's your communication of information. That's your communication of information section there. We have next up, this is the actual mark scheme. Okay, so we have some things called functional and non-functional requirements. Okay, what is functional requirements or what is non-functional requirements? Functional requirements are things that the program must be able to do, right, for a particular scenario. So functional requirements are essentially if it is that you have a business that you are looking at, and yeah, that's within your problem definition. What I want you to do is I want you to list the important things that the program must be able to do. So say for instance, we have a what you call it? Let's say we have a school, right? We want to write a program for teachers to keep track of students' grades. Some functional requirements for that system is that you must be able to add a teacher to the system. You must be able to add a student to the system. You must be able to add a grade into the system. You must be able to record the student's class. You must be able to calculate the student's grade average. You must be able to calculate a class's grade average. These are things that are required to solve the problem. Whereas a non-functional requirement is something that is desirable for the program to the point where it will not be accepted by the person who it is intended for. And a non-functional requirement is something like the program must sort all students alphabetically, or it must sort all students by class. Now, those things are not technically required for the program to work, for the program to deliver its intended purpose, which is to manage and manipulate grades. What it is that it adds value to the program. You follow me? So non-functional requirements could be something like, again, you require a password to access the data, right? If you have to access all students' data, you are required to put in a password. That's a non-functional requirement of the system. Why? That password has nothing to do with sorting, with adding students and finding grades, etc. But it is something that adds value to the system. You all with me?
Yes, sir.
Yes.
Okay, great. Next up is this section is 4. So you're writing up like a program specification, and then you identifying exactly what they want functionally and non-functionally. Okay? The design of the system, you're looking at having the system, the system expressed as your flowchart or your pseudocode, right? Your flowchart, of course, must follow the rules of flowchart. It has to be easy to follow. It must be an accurate description of the solution. And you also have to have, of course, your narrative, which I'm not seeing here actually anymore, which is strange. CXE might have made a mistake and left out narrative in this section. But we want to have that description. We want to have that description textually of your system. Okay. So next up, we look at the use of your files. How is your file structured? Right. So we're looking at what files the system uses, how is data kept in the file, etc. We're looking at the file inputs and outputs. We're looking at the file inputs and outputs, what comes into the file, what goes out of the file. We're looking at the use of any data structures. These data structures could be arrays, they could be structs, they could be an array of structs. I typically encourage students to write a solution that has a struct array inside of it. And then we're looking for your demonstration of structured programming concepts. We're looking to ensure that, what are the structured programming concepts, anybody? Structured programming concepts, what are they? Should I call a name? Alexandra. Alexandra?
Yes, sir.
You can remember what we define as structured programming concepts?
No, sir.
No? I'm telling you, when I say it, you're gonna laugh. Uma, I'm sure Uma can tell me.
No, again, in my head, I confused with the other thing, so no, I can't.
So that's just not like your loops in it?
Yes, Kishan, thank you.
Okay.
Your structured programming concepts as sequence, selection, and iteration. So as long as you have good sequence, your program makes logical sense. As long as you have some if statements inside of there, and as long as you have some loops inside of there, that's 5 marks secured. Again, this is another 8% of your SBA. Okay? Does that bring it to mind now? Is it? Yeah?
Yeah.
Yes,
Just
sir.
tired.
Yeah. Okay. So then we go into coding. Once you use functions and your functions look like independent units, once your functions are there and you could pass data into a function and have data returned from a function, then you're going to get your 6 marks. Using functions is 10% of your SBA. Then we want to make sure that in code, we use loops and conditionals and proper assignment, etc. Once I see this, that's another 3 marks. This one here is huge. Programming style and documentation. I just see my indentation and my white spaces. I am very hungry for indentation and white spaces, right? Now you know me. I don't like to see something poorly indented. I don't like to see code trick up together. So once you have your documentation, once your code looks neat, you get your 4 marks. This year, there's 4 marks, and this is what I was talking about earlier, that your code needs to match your algorithm. Your code needs to match your algorithm. So what this means is that it means that your code and your algorithm need to make the same logical sense. There are some things when you're representing it in pseudocode, or if you're representing it in flowcharts, right? Then it's a little different in terms of how it's implemented. But if it is that they're too far off, then you don't get your marks. I don't really have problems with students on this here. And then we have evidence of file manipulation, right? Once you read in your text file, we're only using text files. Okay, we're not going into binary files, etc. This is really not even on the syllabus to learn binary files and whatever. Once we have our text file and it's used in a way that makes sense, you read a simple text file, you write a simple text file, you get your 2 marks. We will do up a test plan. Your testing is 11 marks, right? Your test plan, you show up your test, you show your test plan. You need to test in 4 categories. I will go through the test plan a little later, closer to when we have to do it. And you show what results your test give. You know, these are the test categories you have. Normal input, it's normal result. Extreme input, right, given some sort of error message. If you have straight up erroneous input, then it should also give an error message. If you have incomplete input, like if your program is expecting something and it didn't get everything, then it should also give an appropriate message. We have the appropriate cover page. So you have to have a cover page, right? Your cover page must have your the title of your project, your student number, your school number. You need to have the year of the project as well. You have to have a table of contents, and your table of contents must match what is actually in the document. And the document must follow this here. This is what your document must follow. So don't have your coding as first thing and then definition somewhere near the end, and testing wherever you want to put it. You have to have the document as you must have the document in the order that it should be. And that's it, right? Sorry, you have no, they want some documentation. All right, so this is new. This is new. They want technical documentation and user documentation. So you have to now write some technical documentation which shows, I would say that you would have a HIPO chart, okay? You say what inputs go into what parts of the program, how it works, what processing is done, and what is expected to be output from it. And you have some user documentation. Just like on the user side, you kind of write out how the program works. Like you just say, well, upon, and I think this is more your narrative here now. Okay, because remember I said that I'm not seeing the narrative to the top where it used to be. This is your narrative here now. This is when the program starts, you are expected to be greeted with a menu screen. And you can put in a little screenshot of the menu screen. And then you could go through with the user each menu option and what it will do, right? Like if it's a manual. Not too much words, because we only have 1,500 words to work with for the whole SBA. All right. Again, I will show you how to do the HIPO chart for the technical documentation. Everybody is fine with this?
Yes, sir.
Right. The thing is, once you have identified a sufficiently quality SBA, this SBA, especially with these aspects here of the technical documentation and the user documentation, it will carry over to Unit 2, where I make you all work in groups for Unit 2. And really and truly what you are doing is that you're going to have to come up with the system documentation aspect in terms of development to go along with this SB, so that there's not much tweaking that has to be done in Unit 2, right? So, you know, it's a situation where you have to put in the work now. All right, Clement, you all right? You with me?
So, by chance, it have an example of this SBA thing?
Yeah, I do. I'm never too keen to give students specific examples like from past SBAs, because of the fact that you tend to do it that specific way, right? What I would say is start, and you know, this is, so I'm basically saying, and I'm not going to give you any more of an example than when the time comes, I will show you what to do, and I want you to do it yourself. Because you know, somehow you give students 2-3 examples of what went in the past, and students kind of follow that as a Bible, right? Whereas what we want is for people to come up with their own unique aspects of an SB. All right, so for now, identify your scenario and think about the functional and non-functional things that you want your project to do. Okay? I will essentially be going through this today, this one here, and I will be going through the coding. We'll start with the coding here of what we want to do for that particular example. No problem? All right. So take a 2-minute break, just breathe, walk around, get yourself a little more active, and then we're going into these functional and non-functional requirements. I'm going to pause the recording.